Very good evening, students.
Good
Good
afternoon,
evening,
sir.
sir.
Yes, good afternoon, good evening. So let us start the discussion without wasting any time. If you remember last class, we were discussing about chemical kinetics, and there we have classified three types of reactions. Like based on the rate of the reaction, we have said there are three types of reactions: very fast reactions, very slow reactions, and moderate reactions. Moderate reactions will have the rate whose kinetics can be studied, whereas very fast and very slow reactions kinetics cannot be studied. If we proceed further, so what actually is rate of reaction? Rate is nothing but change in some quantity. Rate is nothing but change in some quantity divided by time required for that change. Time required for that change. So generally, what is the quantity which is going to be which is going to be changed in a chemical reaction? In a chemical reaction, generally concentration changes, or if all the reactants and products are in the gaseous state, then pressure can changes. So rate of reaction is defined as a change in concentration or pressure of the reactant or product per unit time. So it is a positive quantity always. So rate of reaction is equals to change in concentration of reactant or product divided by time taken for that change. Let us take a reaction like A is converting into B. A is the reactant, B is the product. At time t is equal to 0, reactants are going to be converting into products. At time t is equal to 0, reactants are going to be converting into products. Like A is converting into products means reactants has a tendency to convert into products. At time t is equal to 0, what was the concentration of reactants? Concentration of A is maximum, and concentration of B is 0. As time proceeds, what happened to the concentration of A?
Decreases.
Decreases.
Concentration of A decreases and the concentration of B increases. So you can think of this decrease in the concentration of A and increase in the concentration of B. How the concentration of A decreases? Concentration of A is going to be decreasing, but it is an exponential decrease or linear decrease?
Exponential decrease.
Exponential decrease. Yes or no? So you have the reaction like concentration versus time graph. If you try to plot at time t is equal to 0, we have maximum concentration of reactant max. So as the time proceeds, concentration of reactant is decreasing and concentration of product is increasing. And the concentration of reactant and concentration of product, they increase or decrease exponentially, not linearly. For any reaction like reactant converting to product, this was the scenario. What was the unit of rate of reaction? Rate is equals to change in concentration. That is, concentration is molar by time required for the change. So unit is going to be mole. Molar means mole per liter. So mole liter inverse, time inverse. Time you can measure in seconds or hour or minute. You can write that. So this was the unit of rate of the reaction. So rate is equal to plus or minus delta. Delta represents change in concentration. C represents concentration divided by delta T, time required for that change. Plus or minus, you have to write the plus symbol whenever you write the change in concentration for products, because the concentration of product is increasing over time. But whenever we are writing with respect to reactant, you have to use a minus sign. Rate is equals to, like for the same reaction R to P, you can use plus a delta P by delta T, that is also equal to minus a delta R by delta T, because the change in concentration of the reactant will be negative for the reactant because its concentration is decreasing. So minus delta R becomes positive, minus delta R by delta T, that is again positive, so rate is positive. Where delta C is the change in concentration in small time interval delta T. Plus sign is used when we refer for product concentration or appearance of product, and we use minus sign whenever we are talking with respect to reactant, because concentration of reactants is decreasing over time and concentration of products is increasing over time. Is that clear, students?
Yes, sir.
Yes, right. Very good. For a gaseous reactant, whenever we have a gaseous reactant, we can use plus or minus delta P by delta T, because the concentration of product is going to change. And we know PV is equals to nRT is the ideal gas equation. Let us assume whatever the gases we have in that reaction mixture, They are all ideal in nature. And this is the ideal gas equation. PV is equal to nRT. So P is equals to number of moles by volume into R into T. So number of moles by volume is concentration. P is equal to C into R into T. So concentration C is equals to P by RT. Concentration C is equals to P by RT. So I can write R is equals to plus or minus delta C by delta T. So delta C I can write as delta P by RT. So plus or minus 1 by RT into delta P by delta T. I can write R is equal to plus or minus 1 by RT delta P by delta T. You may also ask a question. Sir, you have written directly rate of reaction R is equal to plus or minus delta P by delta T. Now we are writing R is equal to plus or minus 1 by RT into delta P by delta T. Which one is correct? Like look at this equation, R is equal to plus or minus delta P by delta T. And look at this equation, R is equal to plus or minus 1 by RT delta P by delta T. Because concentration is equal to P by RT. Which one is correct out of
Both
these
are
two?
correct. Both are
Both are
correct.
correct. Yes, very good. Both are correct. The units are different. Here the unit of rate is pressure time inverse, whereas here the unit of rate is mole time inverse, like molar time inverse. So we can write the same expression. R is equals to 1 by RT into plus or minus delta P by delta T. Unit of rates are going to be changed. The formula are going to be same. R is equal to plus or minus delta P by delta T. R is equal to 1 by RT into plus or minus delta P by delta T. Both the equations, both the formula are correct. But the unit of rate, they are going to be different. Right? Where capital R is a universal gas constant whose value is 0.0821 liter atmosphere Kelvin inverse mole inverse, or 2 calories Kelvin inverse mole inverse, or 8.314 joule Kelvin inverse mole inverse. So those are the units of values of R in different units. We all know that. Types of rate of reaction. Rate of reaction, there are two types of rates of reaction, like average rate of the reaction as well as instantaneous rate of reaction. Average rate means rate measured over a long time interval or a measurable time interval. Instantaneous rate is a rate measured over a very small time interval. That seems to be, that time interval is almost very less. That seems to be like an instant of time. Average rate is nothing but, whenever I am talking about average rate, R average is equals to plus or minus delta C by delta T we write. Whereas R instantaneous will write as plus or minus dt, dC by dt we write. dC by dt. That means for a very small time interval, the delta C change in concentration become dC. Yes or no? Or you can say instantaneous rate is equals to, R instantaneous is equals to limit delta T tending to 0, R average. As the time interval is tending to 0, the average rate becomes the instantaneous rate. Limit delta T tending to 0. Delta T is the change in time interval. If that is tending to 0, that means that is approaching to 0, that is near to 0. Delta T is approaching to 0 means what? The change in time interval is approaching to 0 means that seems to be an instant of time or not? Yes or no? Like now,
Yes.
like 1540, the time is 1540, some seconds, some milliseconds. Immediately after some milliseconds, we will be having another time interval, t plus dt. So that what is the time elapsed between t and t plus dt? dt. That dt is a very small time interval that will be tending to 0. If that time interval is tending to 0, then the average rate becomes the instantaneous rate. Average rate is the rate of the reaction over a certain measurable period of time during the course of reaction. That is also denoted by R bar. Instantaneous rate, the rate of reaction at any particular instant during the course of reaction, that is called as instantaneous rate. Rate at 20 seconds is 20 molar second inverse, whereas rate between 10 second to 20 second is 20 molar second inverse. 10 second to 20 second, you can see the time interval. 10 second is there. Rate at 20 seconds, that is different. Yes or no? At 20 seconds means it's an instantaneous rate. Between 10 second to 20 second means that is the average rate. Next, average rate of reaction. The rate of reaction over a certain measurable period of time during the course of reaction is called average rate. It is denoted by R bar. Example, you can take reaction A to B. Yes or no? So like at time t1 concentration of reactant is concentration of A1, at time t2 concentration of reactant is concentration of A2. So what is the average rate? R average is equals to, for reactant, what you have to write? Use the plus symbol or minus symbol?
Minus symbol.
Minus symbol, and a change in concentration of A divided by time required for the change, minus of changing concentration of A means concentration of A at time T2 is concentration of A2 minus concentration of concentration of reactant at time T1 is concentration of A1 divided by T2 minus T1. Which is greater among concentration of A at T2 and T1? Which is greater?
A1.
A1 is greater.
A1. So I'll get minus of, so concentration of A1 minus concentration of A at T2, like time T2 divided by T2 minus T1. So ultimately it is a positive quantity. Rate is always a positive quantity. So R average is equals to minus of delta concentration of A by delta T, and this was the formula. Average rate of reaction, like the same average rate you can measure with respect to product also. At time T1, concentration of product is concentration of B1. At time T2, concentration of product is concentration of B2. So R average is equals to, for product I have to use a plus sign.
Plus.
Yes, very good. Change in concentration of B divided by time taken for that change. So plus of concentration of B at time T2 minus concentration of B at time T1 divided by T2 minus T1. So this is again a positive quantity. Is that clear, students?
Yes, sir.
Yes, sir.
Yes, sir.
Right. These are very simple discussions, very basic points. Instantaneous rate means now whatever the time T1, time T2 we have, that time interval we have to reduce and we have to make delta T to be 0. So it seems to be an instant of time. So for a reaction A to B, instantaneous rate, instantaneous R instantaneous is equals to limit delta T tending to 0 R average. That is, as delta T, the change in time interval is tending to 0, the average rate of the reaction is nothing but instantaneous rate. So R instantaneous is equal to limit delta T tending to 0. R average I can write with respect to reactant as well as with respect to product. So minus of delta concentration of A by delta T, that is equals to plus limit delta T tending to 0, delta concentration of B by delta T. So our R instantaneous you can write as minus of, whenever delta T tending to 0, if the change is tending to 0, we write dt. Yes or no? So minus of d concentration of A by dt, that is equal to plus d concentration of B by dt. Concentration versus time graph. So this, the time interval is going to be very small now. That is, it seems to be an instant of time. At time t is equal to 3 seconds, R instantaneous is equals to minus d concentration of A by dt. It is not like over some time t1 to t2. It is at an instant of time t. Right? And you can actually measure that from the respective slope. Yes or no? Instantaneous rate of the reaction is calculated graphically by drawing a tangent at that time on concentration versus time graph, and the slope of these tangents gives the instantaneous rate. Slope of that particular tangent will be giving the instantaneous rate, because at this particular point you are drawing a tangent. This is your theta. So tan theta is nothing but d concentration of A by dt. Yes or no? Because dy by dx. Dy by dx, if you do the dy by dx, you get the respect to tan theta slope. Yes or no? From the mathematical knowledge also, if a graph has been given to you and the tangent at that particular point is touching the x-axis with and making an angle theta, so tan theta is nothing but slope of that particular straight line or tangent. The slope is nothing but the instantaneous rate. Right? These are the very introduction parts regarding rate of the reaction. Next points: rate of disappearance, rate of appearance, and rate of reaction. So example, you can take N2 plus 3H2 gives us 2NH3. So very simple point. Rate of disappearance means minus of change in concentration of N2 by time required for that change. So minus of delta, because N2 is a reactant, you have to use minus sign. Change in concentration of N2 by time required for the change. So minus of 4 minus 5 by 10 minus 0. That is 1 by 10 seconds. Understand this. In the rate of disappearance of any reactant or rate of appearance of any product, we will not be having any stoichiometric coefficients. It's just a change in concentration by time required for that change. But whenever we have a rate of reaction is equals to minus of change in concentration of N2 by delta T, that is equal to minus 1 by 3, because whatever the stoichiometric coefficient we have before H2, that you have to write in the rate of reaction, because with respect to 1 mole of reactant, how the reaction is happening, that you have to find out. So minus of rate of reaction is always minus of change in concentration of N2 by time required for that change, minus 1 by 3 of change in concentration of H2 divided by time required for that change, that is equals to plus 1 by 2 times that of change in concentration of NH3 by time required for that change. From here, can I say minus delta concentration of N2 by delta T is rate of disappearance of N2. In the rate of disappearance of N2 itself, we have minus sign. Similarly, minus delta concentration of H2 by delta T is rate of disappearance of H2. Rate of disappearance of H2 is equal to 1/3 of rate of disappearance of H2, that is equals to plus a delta concentration of H3 by delta T, that is half of rate of appearance of NH3. So whenever the rate of appearance or disappearance are given to you, you can actually relate one with the other quantity or not. Yes or no?
Yes, sir.
Remember, rate of disappearance itself includes the minus sign. Rate of appearance itself includes the plus sign. Rate of reaction, in that rate of reaction only you will have the stoichiometric coefficient, not in rate of disappearance or rate of appearance. Like that, rate of reaction you can calculate with respect to any species, like any reactant or any product, you will get the same value. You will get only 1 by 10 molar second inverse. But rate of disappearance, rate of appearance, they are going to be different. Right? Example, you take an example, N2 plus 3H2 gives us to 2NH3. Rate of disappearance earlier we have written with respect to average rate, because we have used delta sign, minus of change in concentration of N2 by time required for that change. But now you are using minus deconcentration of N2 by dt. Minus of deconcentration of N2 by dt I can use, where deconcentration of N2 by dt indicates the instantaneous rate. Again, I can write the same value. Rate of reaction is equals to minus deconcentration of N2 by dt is equals to minus 1 by 3 deconcentration of H2 divided by dt, that is equals to plus 1 by 2 deconcentration of NH3 divided by dt. So rate of reaction is equals to minus deconcentration of N2 by dt minus 1/3 deconcentration of H2 by dt plus 1 by 2 deconcentration of NH3 by dt. So from here again you can relate the same. Got it or not? Rate of appearance, rate of disappearance, and rate of reaction. ROR indicates the rate of reaction. Is that clear to everyone? What
Yes,
are the
sir.
point of
Yes, sir.
yes, right? Rate of reaction is a hypothetical quantity which is defined as the rate of disappearance or rate of appearance of any reactive or product per unit of its respective stoichiometric coefficient. Rate of reaction you define with respect to per unit of its stoichiometric coefficient. We'll solve examples after this. We'll get more clarity. For any reaction like A moles of A plus B moles of B gives rise to C moles of C plus D moles of D, what I can write? Rate of reaction I can write as 1 by A minus D concentration of A by dt, that is equals to 1 by B minus D concentration of B by dt,
Minus
that is equal to plus
is equals to 1
plus
by
1
C.
by C D
D
concentration of C by
concentration
dt. Very good. That is equal to plus 1 by
plus
D plus D concentration of D by dt. So that is nothing but your rate of reaction. This is your rate of disappearance of A. This is rate of disappearance of A. What is this? Rate of disappearance of B. What is this? Rate of appearance of C. What is this? Rate of appearance of D. Rate of disappearance of A, rate of disappearance of B, rate of appearance of C and D, rate of reaction, all these we have calculated. Rate of reaction is always positive quantity. Rate of reaction is always a positive quantity. Negative sign represents decrease in the concentration of reactant, whereas positive sign indicates increase in the concentration of product. Right, very good. Mole liter inverse time inverse, that is mole liter inverse second inverse, or mole liter inverse minute inverse, or mole liter inverse hour inverse, that is the unit of rate. Try to solve this example. For the reaction N2 plus 3H2 gives rise to NH3. If the rate of appearance of NH3 given, then calculate the rate of disappearance of N2 and H2 and also rate of reaction. This was the reaction given to you. N2 plus 3H2 gives rise to 2NH3. What is rate of appearance? Rate of appearance of NH3 is what? That is equals to minus of change in concentration of NH3 divided by time taken for that change. That is equals to given as 2 into 10 power minus 4 molar second inverse. We know rate of reaction is equals to minus of change in concentration of N2 divided by time required for that change. That is equals to minus 1 by 3 change in concentration of H2 divided by time required for that change. That is equals to plus 1 by 2 change in concentration of NH3 divided by time required for that change. From here I can calculate, I can also relate rate of disappearance of N2 is equals to 1/3 of rate of disappearance of H2, that is equals to half of rate of appearance of NH3. So that means rate of disappearance of N2 is equals to half of 2 into half of rate of appearance of NH3. Rate of appearance of NH3 is given as 2 into 10 power minus 4. So rate of disappearance of N2 is how much? 10 power minus 4 molar second inverse. Similarly, rate of disappearance of H2 is equals to, I can relate these two. I can multiply these two with 3. Rate of disappearance of H2 will be 3 by 2 times that of 2 into 10 power minus 4 molar second inverse. That becomes 3 into 10 power minus 4 molar second inverse. And therefore, what is rate of reaction? Rate of reaction is nothing but half of rate of appearance of NH3. So half of 2 into 10 power minus 4 molar second inverse. That is nothing but 10 power minus 4 molar second inverse.
Molar second.
Yes, very good. Is that clear?
Yes.
Yes, sir.
Try to solve this question. 2A gives rise to 3B plus 4C. Number of moles of B increased by 16 to 10 power minus 3 mole in 10 seconds in 10 liter container. Find out the rate of appearance of B and C and rate of disappearance of A and rate of the reaction. So reaction is 2A gives rise to 3B plus 4C. And number of moles of B increased. Like I'll be calculating with respect to B. What I can say, rate of appearance of B is equals to what? Minus of change in concentration of B divided by time taken for that change. Minus or plus? Plus we have to use because it is a product. Plus of the change in concentration of B by time required for the change. So 1 by delta T into what is change in concentration of B? Concentration is equal to number of moles by volume. So 1 by V into change in the number of moles. So therefore, rate of appearance of B, I can say it as 1 by delta T. How much is the time interval? 10 seconds. So 1 by 10 into concentration is equals to number of moles by volume. How many moles increased? 6 into 10 power minus 3. In how much? In how many liters? So 10 liter.
10 liters.
So what was the rate of appearance of B? 6 into 10 power minus 5 molar second inverse. Rate of appearance of B is 6 into 10 power minus 5 molar second inverse. So instead of directly giving the rate of appearance of B, they have you given how many moles of B have been increased, in how much time, in how much volume. So for that reaction, 2A gives rise to 3B plus 4C. What I can write? Rate of reaction is equals to minus of change in concentration of A divided by time taken for that change with a 1 by 2. That is equals to 1 by 3 times that of plus a change in concentration of B divided by time required for that change, that is equal to 1 by 4 plus a change in concentration of C divided by time taken for that change. That implies half of rate of disappearance of A is equals to 1/3 of rate of appearance of B, that is equal to 1/4 of rate of appearance of C. I know this quantity, rate of appearance of B. I want to calculate rate of disappearance of A. Rate of disappearance of A is equals to, can I say 2 by 3 times root of rate of appearance of B? That is equal to 2 by 3 times root of 6 into 10 power minus 5. That is equals to 4 into 10 power minus 5 molar second inverse. Similarly, I can relate these two quantities. From there, I can write rate of appearance of C. Rate of appearance of C is equals to how much? 4 by 3 times root of 4 by 3 times root of rate of appearance of B. That is equal to 4 by 3 times root of 6 into 10 power minus 5 molar second inverse. That is how much?
8
8
into 10 power minus 5.
Very good. 8 into 10
So
power
what
minus
about
5 molar.
little inverse?
Yes, very good. 8 into 10 power minus 5 molar second inverse. So rate of appearance of B, rate of disappearance of A, rate of appearance of C, and ultimately rate of reaction also we have to report. Rate of reaction is with respect to any quantity you can calculate. So half of rate of disappearance of A. Rate of disappearance of A is 4 into 10 power minus 5 molar second inverse. So rate of reaction is 2 into 10 power minus 5 molar second inverse. This is rate of appearance of C. This is rate of reaction. Rate of disappearance of A. This is rate of appearance of B. Yes, everything we have reported or not? Right. You try to answer this question. For the reaction x plus 2y gives rise to 4z, the correct statement is x plus 2y gives rise to 4z. You can write down rate of reaction is equals to minus change in concentration of x by time required for that change, half of minus change in concentration of y by time required for that change. Chris, you can write molar means what? Molar means mole per liter. Concentration is equals to number of moles by volume, right? Concentration I'm writing molar. So if you want to remove this capital M, you can write mole per liter, mole liter moles. Okay. Capital M, if you want to remove, you can simply replace capital M with mole per liter. Right. Rate of reaction is equals to minus of changing concentration of x by time taken for that change, half of minus changing concentration of y by time required for that change. That is equals to 1 by 4 times it of plus changing concentration of z by time required for that change. Here I can write rate of disappearance, right? X is rate of disappearance of x is equals to half of rate of disappearance of y, that is equals to 1/4 of rate of appearance of z. So I can write here rate of disappearance of x is twice that of disappearance of y. That is wrong. Rate of appearance of z is 1/4 of rate of disappearance of x. No, rate of appearance of z is 4 times that of rate of, that is also wrong. Rate of appearance of z. Rate of appearance of z is 4 by 2, 2 times that of 2 times that of rate of disappearance of y. So option 3 will be right option. None of the above is correct. This is also wrong. Okay, option 3 will be right option.
Yes, sir.
Yes, right. For the reaction XA gives rise to YB, if 0.48 plus logarithm of minus d concentration of A by dt is equal to 0.78 plus logarithm of plus d concentration of B by dt. So I can write this equation, logarithm of minus d concentration of A by dt minus of I'm rearing this. I'm taking this 0.48 to the other side, and this log plus d concentration of B to this side. Logarithm of minus d concentration of A divided by dt minus logarithm of plus the d concentration of B divided by dt is equals to 0.7 minus 0.48. I can write the expression as logarithm of minus the d concentration of A by dt whole divided by plus the d concentration of B by dt is equals to 0.7 minus 0.48, how much? 0.22.
0.22.
So I can write this as minus d concentration of A by dt whole divided by plus the d concentration of B by dt is equals to 10 power 0.22. For this equation XA gives rise to YB, I can write as 1 by x minus d concentration of A by dt is equals to 1 by y plus a d concentration of B by dt. So that means minus d concentration of B by dt whole divided by plus the d concentration of B by dt is equals to x by y. So here this is nothing but therefore x by y is equals to 10 power 0.22 divided by 1. So that was the ratio. A gaseous is converting into 2B gaseous plus C gaseous. In this reaction, pressure increases from 10 mm of Hg to 140 mm of Hg in 10 seconds. Then find out rate of reaction in mmHg of second inverse, molar second inverse at 27 degrees Celsius. A gaseous is converting into 2B gaseous plus C gaseous. In this reaction, pressure increases from 100 mm of Hg to 140 mm of Hg in 10 seconds. 100 to 140 increase is happening in 10 seconds. Then find out rate in mm of Hg. Rate is equals to, how I can calculate rate? In this reaction, pressure increases from 100 mm to 140 mm in 10 seconds. How I can report the rate? Rate is equals to change in
Delta P.
concentration. Yes or no? Change in pressure divided by time required for that change. You can write 140 minus 100, that will be 40 divided by 10 or not?
Yes.
Yes or no? So delta P is nothing but 140 minus 100, that is nothing but 40 mm of Hg divided by change in time is 10 second, that is nothing but 4 mm of Hg second inverse. This is the rate in terms of pressure. Now we can also report the rate in terms of molar second inverse, because we know P, pressure P is equals to number of moles by volume into R into T. So P is equal to concentration into R into T. So concentration is equals to P by RT. Concentration is equals to P by RT. So I can write the R average. R average is equals to change in concentration divided by time taken for that change. So what is the change in concentration? Because rate is always positive, you don't need to worry with that. Concentration is equal to pressure by RT. So 1 by delta T into, so 1 by RT times that of delta P. It is the rate average in terms of molar second inverse. So 1 by delta T, what is delta T? 10 seconds into 1 by R. R value is how much? 0.0821 liter atmosphere mole inverse Kelvin inverse. T time is temperature is how much? 27 degrees Celsius means 300 Kelvin. Delta P is how much? Delta P 40 mm of Hg. Mm of Hg. You have to convert that mm of Hg again into atmosphere. So what you can write down, students? 40 into 1 mm of Hg is how much? 760.
760
Yeah, 760 mm of Hg is
180.
1 atmosphere. So 1 mm of Hg is 1 divided by 760 atmosphere. So you can convert that 1 by 760 atmosphere whole divided by 10 second into 0. Kelvin inverse Kelvin gets cancels out. Yes or no? Like you have second inverse, units we will write again. So 0.0821 liter atmosphere mole inverse. That's it, right? Mole inverse into 300 to 300. So atmosphere gets cancelled out. You have seconds. Second inverse, mole inverse become mole. So units are going to be mole, liter inverse means molar second inverse. Now you can do the calculation. Calculation you do 40 divided by 10 into 0.0821 into 300 into 760. These many molar second inverse. That is the rate of the reaction in terms of molar second inverse. This is the rate in terms of of Hg second inverse. So same rate is going to be the same, but the units in which you are representing that has been changed. Right. Let us proceed further. A gives rise to NB, concentration versus time graph again. Rate of disappearance, rate of appearance in between 0 to 1 second, and the value of n we have to find out. Rate of disappearance, how to find out? Rate of disappearance of A. Rate of disappearance of A is equals to minus of concentration of A. Rate of disappearance of A means minus of concentration of A. Concentration of A, you know, at time t is equal to 0 and time t is equal to 1. Concentration of A at time t is equal to 1 second is at time t is equal to 1 second minus concentration of A at time t is equal to 0 second whole divided by 1 minus 0. So minus of, what is the concentration of A at time t is equal to 1 second? 0.5. Time concentration of A at time t is equal to 0 seconds is 0.6 divided by 1 minus 0. Minus 0.1 minus of minus that become plus. So 0.1 molar second inverse. That is nothing but your rate of disappearance of A. Rate of appearance of B is how much? Plus you have to write concentration of B at time t is equal to 1 second minus concentration of B at time t is equal to 0 second divided by 1 minus 0. Concentration of B at time t is equal to 1 second is 0.3, 0.3 and 0. 0.3 minus 0 is 0.3 divided by 1. 0.3 molar second inverse. And we know A gives rise to NB is the reaction. Rate of reaction is equals to minus change in concentration of A divided by time required for that change, that is equals to plus 1 by n change in concentration of B divided by time required for that change. I can write this expression as rate of disappearance of A is equals to 1 by n times that of rate of appearance of B. What is rate of disappearance of A? 0.1 molar second inverse. That is equals to 1 by n times that of rate of appearance of B is 0.3 molar second inverse. Molar second inverse cancels out. So n is equal to 0.3 by 0.1, that is equals to 3. Everyone got it or not? N is equals to 3.
Yes, sir.
Yes, sir.
Yes. Check out the calculations. Calculations plays an important role. So if you do wrong calculation, even though you know all the concept, you will get negative mark. No one is going to check whether you know the concept or not, right? You know how to solve it or not. Ultimately, you have to score it. That is the only way, because lakhs of students are writing. So concentration plays an important role. So check it carefully. So after these concepts, we then have the rate law. Rate law, according to rate law, how the rate of reaction can be written as. So rate law is actually given by experimental quantity. The experimental expression of rate of reaction in terms of concentration of reactants is known as rate law rate expression. For example, you have a reaction like this. In a chemical reaction, A moles of A plus B moles of B gives rise to product. Rate of the reaction is directly proportional to concentration of A power X into concentration of B power Y. What are X and Y? X and Y are determined experimentally. X and Y are determined experimentally they are the X is the order with respect to A, Y is the order with respect to B. We'll define what is order and all. So X and Y are those quantities which are determined experimentally. They are not simply A and B. For the same reaction, A moles of A plus B moles of B gives rise to product. Rate is directly proportional to concentration of A whole power A into concentration of B whole power B. This is according to law of mass action. Yes or no? According to law of mass action, we can simply write rate is directly proportional to concentration of A into concentration of B raised to the power of respect to stoichiometric coefficients. But that is not true when you come to the experimental data, that is rate law. In reality, this is the approximation. This is the approximation where you assume all the A moles of A and B moles of B are effectively colliding. But in reality, let us take 1 mole of A and 2 moles of B. Can we say all the 1 mole of A and 2 moles of B, all the reactants are colliding effectively? We can't say that. Can we say that? We can't say that. So rate of the reaction is proportional to concentration of A whole power A into concentration of B whole power B. That is the rate equation given by law of mass action, which is not, may or may not be true. I'm not saying it is always wrong with respect to experimental. It may be true. It is true for elementary reactions. So according to law of mass action, whatever the rate expression given, that expression and the rate law, they may or may not be true for all the reactions. Okay. In this reaction, the rate of, in this expression, the rate of the reaction is proportional to product of molar concentration of reactants with each term raised to the power of exponent that has to be found experimentally. That is, X and Y values have to be found experimentally. X and Y may or may not be equal to stoichiometric coefficients A and B. Okay. And you may ask a question like, sir, why the rate of the reaction has to be proportional to concentrations? I have explained them in chemical equilibrium as well, if you remember. Why the rate of the reaction has to be proportional to concentration? Because how the reaction is proceeding, the reactant molecules are actually colliding with each other, with themselves to form the product. Yes or no? React collisions are directly proportional to product formation. Product formation again directly proportional to rate of reaction. And also collisions are directly proportional to number of molecules. Because more number of molecules, more number of collisions. Number of molecules again directly proportional to concentration. So I can say rate of reaction should be directly proportional to concentration or not. Because the reactant molecules are colliding with each other. The reactant molecules, these two water bottles are two reactant molecules, they are colliding with each other. Because of collision, like if the reactant molecules possess minimum amount of energy and proper orientation, then only they will form products. Whenever they are colliding, if more number of reactant molecules are colliding, more will be product formation. More number of reactant molecules means concentration is number of moles by volume, number of moles. 1 mole will have Avogadro number of molecules. Greater the number of moles, greater will be the number of molecules. Greater the number of molecules, greater will be the collisions. Greater the number of collisions, greater the product formation. Obviously, greater the rate of the reaction. Is that clear?
Yes, sir.
Yes, sir.
Yes, right. And I can say law of mass action is actually a special case. Law of mass action is a special case of law of mass action is a special case of rate law. Rate law is the generalized case where law of mass action is a special case. If concentration of B is doubled, if you are doubling the concentration of B, rate of reaction does not change. So for this expression, if a rate of reaction is not changing even though you change the concentration of B, can I say rate is independent of concentration of B?
Yes, sir.
Yes.
Obviously, even though I am changing the concentration of B, rate of reaction is not changing means rate is not depending upon the concentration of B. Concentration of A is doubled, then rate of reaction also doubled, let us say. In that case, what you can say? If rate of reaction become double when the concentration of A is double, rate is directly proportional to concentration of A power 1. Rate law. In a chemical reaction, A moles of A plus B moles of B gives rise to products. From the rate law, we can say rate is directly proportional to concentration of A power X into concentration of B power Y. The values of exponents X and Y are found experimentally, which may or may not be same as that of stoichiometric coefficients. So whenever there's a proportionality, I have to remove the proportionality and insert a constant. So rate is equal to some constant K, rate constant, into concentration of A whole power X into concentration of B whole power Y, where K is the proportionality constant known as rate constant or specific reaction rate. So rate is equals to K into concentration, like for the reaction A gives rise to B for nth order. So rate is equals to K into concentration of A whole power n. I am writing. What is the unit of rate? Concentration divided by time. That is equals to K into concentration whole power n. So K should be equivalent to concentration power 1 minus n into time power minus 1. So K should be equivalent to mole power 1 minus n liter power n minus 1 time inverse. This is going to be the unit of rate constant. Whenever n is equals to 0, what happens? K is equals to n is equal to 0 means unit is what?
Mole liter power minus 1
Mole
time inverse.
liter power minus 1 time inverse. N is equals to 1, K equivalent to just time inverse. So from the unit of rate constant, can I decide the order of reaction?
Yes, sir.
Yes.
Okay, they don't need to specially mention this is the order of this particular reaction. From the unit of the rate constant, which might have been mentioned in the question, you can actually find out the order of reaction. From the unit of rate constant, we can estimate the order of the reaction. From the unit of rate constant, we can estimate the order of the reaction, and that order you can find it out. And what is rate constant? Rate constant is the rate of reaction whenever concentration of all the reactants are 1 molar. So rate of reaction at unit concentration of each reactant involved, like concentration of A 1 molar, concentration of B 1 molar. Whenever I maintain the concentration of A and concentration of B 1 molar, then rate is equals to rate constant K. Rate of reaction at unit concentration of each reactant involved in the reaction, that is nothing but rate constant. That is nothing but rate constant. Rate constant do not depend on concentration of reactant, but it depends upon temperature and catalyst. Very important point. Rate constant do not depend upon concentration. It doesn't mean like I take an iron rod, small iron rod. I want to do the rusting of iron. Small iron rod I have taken. Rusting of iron take months. Imagine the same thing. I have taken a very long iron rod whose concentration is very high in terms of concentration if I talk. Although it is not logical to say iron rod in terms of concentration, it is a metallic rod. But just imagine like small iron rod I have taken and a very large iron rod I have taken. If I take a very long iron rod, will the rusting occurs instantly? No. Same way, if I take A and B, two reactants, and vary the concentrations of A and B, the rate constant is not going to be varied. Rate constant does not depend on concentration of reactant, but it depends upon temperature and catalyst. If you increase the temperature, then the collisions increases, rate of reaction increases, rate constant changes. If I use a catalyst, reaction path changes, rate constant changes because rate of reaction increases. But it is not going to change just by increasing the concentration. Is that clear?
Yes, sir.
Yes. Rate constant do not depend upon concentration of reactant, but depends upon temperature and catalyst. Some important points you can understand. Law of mass action is a special case of rate law, where exponents are equal to stoichiometric coefficients like x and y, they are equal to A and B. According to rate law, we write rate is equals to K into concentration of A power X into concentration of B power Y. According to law of mass action, you write rate is directly proportional to concentration of A power A into concentration of B power B, where the stoichiometric coefficients, whenever they are equal to the exponents in the rate law, then rate law and law of mass action are same. So law of mass action is a theoretical quantity. According to law of mass action, if I take A moles of A and B moles of B, all the moles are colliding and they are forming products, or all the moles are involving in the respective reaction. That is why concentration of A power A has been taken. But in reality, out of A moles of A, some moles of A may be ineffective. So they may not be, like, although we have taken 2 moles of A, all the 2 moles of A may not be effective. So rate concentration of A power 2 may not be all the case. Like rate may be proportional to concentration of A power X. X may be equal to 2 or may not be equal to 2 as well. Order of reaction. The sum of powers of concentrations of reactants in the rate law expression, that is known as order of reaction. The sum of powers of concentration of reactants. All the reactants powers, if you try to add, that is order of the reaction. Like rate is directly proportional to concentration of A power X, concentration of B power Y, concentration of C power Z. X plus Y plus Z is the total order of reaction. X is the order with respect to A, Y is the order with respect to B, Z is the order with respect to C. For the reaction, A moles of A plus B moles of B gives us to product. Rate law, rate is equals to K into concentration of A power X into concentration of B power Y. X is equals to order of reaction with respect to A. Y is equal to order of reaction with respect to B. X plus Y is the overall order of the reaction. Order of reaction is an experimentally determined quantity. It is not the theoretically given quantity. Whatever the stoichiometric coefficients we have, if you are writing that in the law of mass action, that is theoretically given. But order of the reaction is experimentally given quantity, not theoretically given quantity. Is everything clear, students, so far?
Yes, sir.
Right. And order showed what? Order of the reaction may be 0, positive, negative, or fractional. Order shows the dependence of rate of reaction on concentration of reactant. What is order means? You don't need to say like order is the power. Order actually shows us the dependence of rate of reaction. Like how the rate of reaction is dependent on a concentration of any reactant, that is order. It shows dependency of rate of reaction on concentration of the reactant. Right, students, try to solve this question. For a reaction 2A plus B gives us to product, its rate law is R is equals to K into concentration of A whole power X into concentration of B whole power Y. If concentration of A is doubled, rate of reaction becomes doubled, then value of X is how much? So your expression R1 is equals to K into concentration of A whole power X into concentration of B whole power Y. Concentration of A is doubled, rate of reaction becomes doubled. So 2R1 is equals to K into 2 power X into concentration of A power X and concentration of B power Y. So divide these two. R1 gets cancels, KK gets cancels, everything gets cancels out. You get 1 by 2 is equals to 1 by 2 power X. So what is order with respect to X? 1. Second, R1 is equals to K into concentration of A power X into concentration of B power Y. If concentration of A is increased by 4 times, rate of reactions become double. Concentration of A is increased by 4 times. So K into 4 power X into concentration of A power X into concentration of A B or concentration of B power Y. Rate of reaction become doubled. So 2R1. So these are the expressions. R1 cancels out. Everything cancels out. So 1 by 2 is equals to 1 by 2 square whole power X. So 1 by 2 whole power 1 is equals to 1 by 2 whole power 2x. So 2x is equals to 1
1 by 2.
or x is equals to 1 by 2. Third one, R1 is equals to K into concentration of A whole power X into concentration of B whole power Y. If concentration of B is doubled, rate of reaction become half. So 1 by 2 R1 is equals to K into concentration of A whole power X into concentration of B is doubled. So 2 power Y into concentration of B whole power Y. Divide these two. So 2 is equals to 1 by 2 power Y. So I can write 2 is equal to 2 power minus Y. Or you can write 1 is equals to minus Y or Y is equals to minus 1. So order with respect to B in this case is minus 1. Concentration of B is doubled, no change means order is 0. Right? Unit of rate constant. This is what I have discussed. Unit of rate constant is K is equals to mole per liter, that is concentration power 1 minus n into time power minus 1. If it is zero order reaction, what was the unit we got? Mole liter inverse time inverse. If it is first order reaction, what was the unit you got? Just time inverse.
Time inverse.
Second order reaction, mole power minus 1
Mole
liter
inverse.
power 1,
Second
mole power minus 1 liter power 1 time inverse. So with respect to the unit of rate constant, we can actually find out the order of the reaction. With respect to the unit of rate constant, we can actually find out the order of the reaction. Is everything clear?
Yes.
Yes.
Yes, sir.
Try to solve this question. Rate law of gaseous reaction to A plus 2B gaseous gives us to C is given as R is equal to K into concentration of A into concentration of B power 2. Find the effect on rate of reaction. We have to find the effect on rate of reaction if concentration of both A and B are tripled. So first question, how we can solve? R1 is equals to K into concentration of A into concentration of B whole power 2. Find the effect on rate of reaction. R2 is equal to K into 3 concentration of A into 3 concentration of B whole power 2. That is K into 3 into concentration of A into 3 square into concentration of B whole power 2. That is nothing but 27. 3 power 3 is 27 into K into concentration of A into concentration of B whole square. That is 27 R1. R2 is equals to 27 times the rate has been increased. Pressure of only B is halved. R1 is equals to K into partial pair of A into partial pair of B whole square. R2 is equals to K into partial pair of A. B is half means 1 by 2 partial pair of B whole power 2. That means 1 by 4 into R1. R2 is equal to 1 by 4 times that of 1 by 4 times that of K into partial pair of A into partial pair of B whole square. So R2 is equal to 1/4 times that of R1. Third case, volume of container is reduced to 1/4 of the initial volume. Third case, I can say concentration is equals to number of moles by volume. Concentration is equals to number of moles by volume. Volume of container is reduced to 1/4 of initial volume. So the number of moles were not changed. So volume reduced to 1/4 means concentration increased to 4 times or not?
Yes, sir.
Volume reduced to, without changing number of moles, volume reduced to 1/4 means concentration increased by
4 times.
4 times. Therefore, R2 is equals to K into 4 times that of concentration of A into 4 power 2 into concentration of B whole square. That is 4 power 3 into K into concentration of A into concentration of B power 2, that is 64 times that of initial rate. So 64 times the rate of the reaction has been increased whenever you try to decrease the volume of container by 1/4 of its initial volume. Next question, for m moles of A plus n moles of B gives us to P, the concentration of both reactants is doubled. Then the rate of reaction is increased by 8 times. Ma plus Nb gives us to P. Rate is directly proportional to concentration of A power m, concentration of B power n. The concentration of both the reactants is doubled. Rate of reaction is increased by 8 times. And if only concentration of B is doubled, rate of reaction is doubled. Can I use this statement? Concentration of, like here I have written m and n, which should be wrong because we don't know. M and n, if I write, that is law of mass action. So I have to write x and y. If only concentration of B is doubled, rate of reaction is doubled means what is y?
1.
Y should be is equals to 1 because rate of reaction is doubled when concentration of B is doubled. So you can write rate is directly proportional to, or rate is equals to K into concentration of A whole power x into concentration of B. And this is R1. R2 is how much? Rate of reaction increased to 8 times. So 8 R1 is equals to K into 2 power x into concentration of A over power x into 2 into concentration of P. So R1, K concentration of A power x, K concentration of power x, everything gets cancelled. So 1 by 8 is equals to 1 by 2 power x into 2. So 1 by 8 is equals to 1 by 2 power x plus 1. So 1 by 8 I can write as 1 by 2 power 3, right?
Yes, sir. 2.
X plus 1 is equal to 3 or x is equals to 2. So what is the calculated order and rate law equation? Rate law equation is R is equals to K into concentration of A whole power 2 into concentration of B. Total order is 3. Order with respect to A is 2. Order with respect to B is 1. Right?
Yes, sir.
Yes, very good. Try to solve this question. For A plus B gives us to P, when concentration of A is doubled and rate becomes doubled, the rate reaction becomes 2.82 times. When concentration of B is tripled, the rate of reaction is also tripled. Like write the equation R rate is equals to some K into concentration of A power X into concentration of B power Y. When concentration of A is doubled, rate become 2.82 times. 2.82 R is equals to concentration of A is doubled, A into 2 power X into concentration of power X into concentration of B power Y. So R gets cancels, everything gets cancels out. You have 1 by 2.82 is equals to 1 by 2 power X. 2 power X is equals to 2.82. 2.82 is 2 into 1.414. That is 2 into root 2. That is 2 power 3 by 2. 2 power X is equals to 2 power 1 into 2 power 1 by 2 is 2 into 3 power 2 power 3 by 2. So what is X? X is 3 by 2. And rate of concentration of B is tripled when rate of reaction also tripled. Then rate is how much?
Y
Like
1. 1.
Y is equals to 1. X is equal to 3 by 2. So rate law equation R is equals to K into concentration of A power X. X is 3 by 2. Concentration of B power Y. Y is 1. Right?
Yes, sir.
Yes, very good. For the reaction rate law, equation is R is equal to K into concentration of C whole power 3 by 2. Then unit of rate constant will be R is equal to K into concentration power 3 by 2. Rate is concentration by time. That is equivalent to I am writing. So I'll directly cancel out the units. Concentration power 3 by 2. So K equivalent to concentration power 1 minus 3 by 2 into time power minus 1. So K equivalent to concentration is mole
Minus 1.
liter power minus 1 whole power minus 1 by 2 time power minus 1. So K will be having the units of
More
mole
power
power
minus
minus
1.
1 by 2 liter power plus 1 by 2 time
Time.
inverse. That will be the unit of rate constant K for this particular rate expression. Right?
Yes, sir.
Right.
Yes.
From the order of the reaction, find out order of this reaction. A plus B gives us to product. Concentration of A, concentration of B, rate of reaction has been given. Look at this experimental data. From this experimental data, you find out where the rate of reaction is same. Rate of reaction is same in first experiment as well as third experiment. Look at the data now. In the first experiment,
0.
concentration of A is 0.05, concentration of B is 0.05. Third experiment, concentration of A is 0.05, concentration of B is 0.1. That means from the first and third experiment, I can say by keeping the concentration of A constant, even though I change the concentration of B, rate of reaction is not changing.
Yes, sir.
Therefore, rate should be directly proportional to some constant K into concentration of A just power X. There should not be any concentration of B, or you can write concentration of B power 0. It is not dependent. Now look at the first and second. So R1 in the first experiment, how much? 1.2 into 10 power minus 3 is equal to some
0.
constant into, yes, 0.05 whole power. Second experiment, 2.4 into 10 power minus 3 is equal to K into 0.1 whole power X. Divide these two. 1.2 by 2.4 is 1 by 2 is equals to K gets cancels.
5 by
1 by
10.
2,
1 by 2 whole power x.
1 by 2 whole power X. So X is equals to 1. So the rate is equals to K into concentration of A. Or I can simply say by doubling the concentration of A, rate of reaction double, no? So order with respect to A should be 1. Or you can do the experimental data, substitute, do the calculation, you'll get the same. By observing also, you can say I am 0.05 to 0.1 is double, concentration of A double, rate of reaction double. So order with respect to A should be 1, order with respect to B should be 0. So R is equal to K into concentration of A. So what is the order of this reaction? Therefore, order is equal to 1.
1.
Yes. The same question, right?
Yes, sir.
Find out rate constant for this reaction. A2 plus B2 gives us 2AB. So try to solve. I'll be back in just 1 minute. Find out rate constant for this reaction. We have to find out the rate constant for this reaction. A2 plus B2 gives us 2AB. So Faizan says 1.25 into 10 power minus 4. Let us check it out. Okay. Atika, we have to find out the rate constant, right? So ultimately, so with respect to X and Y, you have to ultimately calculate the K value. Look at concentration of A2, concentration of B2, rate of appearance of AB they have given instead of rate of reaction. So let us write the equation. A2 plus B2 gives rise to 2AB. From here I can write rate of reaction is equals to minus of like minus of changing concentration of A2 divided by time taken for that change, that is equals to minus of changing concentration of B2 divided by time required for that change, that is half of plus changing concentration of AB divided by time required for that change. I can write from here rate of reaction is equals to, with respect to AB, what I can write, half of rate of appearance of AB. So I can write rate of appearance of AB is equals to 2 times that of rate of reaction. I'll make the other column rate of reaction is equals to 2 times that of rate of appearance. So I'll just write the value rate of reaction. This is 5 into 10 power minus 4. This will be 10 into, like double I'm doing, because rate of appearance of AB is, sorry, rate of reaction is half of rate of appearance of AB, right? Rate of reaction is half of rate of appearance of AB, right? Half I have to do. I should not do double, I have to do half, because rate of reaction is half of rate of appearance of AB. That is 1.25,
1.25.
2.5
2.5.
into 10 power minus 4, 5 into 10 power minus 4. So these are the rate of reactions. Now you look at rate of reaction is changing even though you change concentration of A2 or concentration of B2. So I have to write the expression R is equals to K into concentration of A power X into concentration of B power Y. This is R1, you can say. R1 you can write in terms of, like I can substitute the values of concentration of A and concentration of B. So K into concentration of A is how much? 0.1 whole power X into 0.1 whole power Y. How much is the rate?
1.25 into
1.25 into 10 power minus 4 is equals to K into 0.1 power X into 0.1 power Y. 2.5 into 10 power minus 4 is equals to K into 0.2 power X into 0.1 power Y. Divide this to 0.1 power Y, 0.1 power Y, K gets cancels, 10 power minus 4 cancels. So 1 by 2 is equals to 0.1 by 0.2 whole power X. So I can write X is equals to 1. So 1 by 2 is equal to 1 by 2 whole power X. So X is equals to 1. Now I take the next two, like what I'm going to take now is, I'll take the experiment 2 and 3. 2.5 into 10 power minus 4 divided by 5 into 10 power minus 4 is equals to K into 0.1 power X, 0.2 power X into 0.1 power Y whole divided by K into 0.2 power X into 0.2 power Y. 10 power minus 4 cancels, K cancels, 0.2 power X cancels. So you get 1 by 2 is equals to 0.1 by 0.2 whole power Y. Again from here I get Y is equals to 1. So what is our rate expression? Rate is equals to K into concentration of A whole power X into concentration of B whole power Y. What is X and Y? X and Y are 1 and 1. Concentration of A power 1 into concentration of B power 1. And now we have to find out the K value. So use any experiment. I'm using experiment 1. So what is rate of reaction? Rate of reaction is how much? 1.25 into 10 power minus 4. That is equal to K into 0.1 into 0.1. So I can say from here K is equals to 1.25 into 10 power minus 2. Yes or no?
sir.
So 1.25 into 10 power minus 2, I'm getting Faizan. Check it out once.
Yes, sir.
Yes, because this 10 power minus 2, 10 power minus 4 gets cancels out, so 10 power minus 2 times. So we'll have this value of K ultimately. Fine, right? So until now we have discussed different types of problems from your rate of reactions and all. Then comes the next concept known as molecularity. Total number of molecules, atoms or ions or reacting species participating in an elementary reaction, that is said to be molecularity. So number of ions, atoms or species in the elementary reaction, that is called as molecularity. Unimolecular reaction like NH4NO2 gives rise to N2 plus 2H2O whenever you heat it. Unimolecular reaction means only one molecule is there in that particular reaction whenever the reaction has been done. So molecularity is going to be 1. Molecularity will be 1. This is NH4NO2 that upon heating forms N2 and 2H2O. Bimolecular means you can have 2HI giving rise to H2 plus I2. Molecularity is 2 because 2 moles of HI are there. So HI molecules will combine upon heating to form H2 and I2. Molecularity is 2, bimolecular. It is also defined as number of reacting species, molecules, atoms or ions that must collide with one another simultaneously to form the products. That is also called as your molecularity. The number of reacting species which are colliding simultaneously to form products. That is also called as molecularity. Trimolecular reaction. Like you can take the reaction like 2NO plus O2 gives us 2NO2. So molecularity in this case is 3 and it is said to be trimolecular reaction. So 2NO plus O2, they are colliding with each other to at high temperature to form 2NO2. To form 2NO2. Molecularity is a theoretical quantity or theoretically given idea. Molecularity, can it be negative?
No,
Molecularity,
sir.
No, sir.
can it be fractional?
No, sir.
No, sir.
Okay, molecularity, can it be greater than 4, greater than 3? Molecularity cannot be negative, it cannot be 0, it cannot be fractional, it cannot be greater than 3 also. Cannot be 0, cannot be negative, cannot be fractional, it cannot be greater than 3 because more than 3 molecules colliding at a particular time is not happening. Okay, molecularity negative,
Fractional.
yes,
0.
fractional, 0 and greater
Greater
than
than 3.
not possible. Molecularity can be only integer 1, 2 or 3. So you may directly ask a question, sir, there are many reactions where we have many number of reactant molecules. So whenever we have many number of reactant molecules, then why you are saying molecularity is like I have a inorganic reaction where I am doing the balancing of uh, potassium permanganate in the acidic medium. So it is converting into different other set of reactions. So I can do the balancing part where I'll be getting more than 3 number of reactant molecules in the reactant side. But in reality, this reaction is happening in many steps. There is some mechanistic approach. Whenever the molecularity is found to be greater than 3, then you have to look at the mechanistic approach of that reaction. From the mechanism, we define molecularity for each and every reaction separately. Molecularity of order greater than 3 is very rare because chances of effective collisions of more than 3 molecules simultaneously at same instant of time is very rare and slow to proceed. That is not possible at all. Okay, you forget the case of very rare. Molecularity greater than 3 is not possible. Elementary reactions. Those reactions which completes in single step are known as elementary reactions or simple reactions. For elementary reactions, exponents in rate law are equal to stoichiometric coefficients. That is, law of mass action and rate law are same. Rate law are same for elementary reactions. For elementary reactions, law of mass action and rate law, they are going to be same. Example 2A plus B gives us to C is an elementary reaction. Then you can say rate law is R is equals to K into concentration of A power 2 into concentration of B. 2A like 2A plus B gives us C means R is equal to K into concentration of A power 2 into concentration of B. Where X is equals to 2, Y is equal to 1, that is the order with respect to A and B. Overall order is 3. Molecularity is also 3. H2 plus I2 gives us to 2HI. It is also an elementary reaction. Then rate law will be rate is equals to K into concentration of H2 into concentration of I2, where X is equal to 1, Y is also equal to 1. Overall order of the reaction is X plus Y, that is equals to N, that is also equal to 2. Molecularity is equal to 2. For elementary reactions, order and molecularity, they are also going to be equal. Their for elementary reaction, order of the reaction is also equal to molecularity of the reaction. Also, law of mass action and rate law are same. Law of mass action and rate law are same. For elementary reaction, order is equal to molecularity of the reaction. And what is the possibility of molecularity? Molecularity can be 1 or 2 or 3. That means whenever you have a rate of a reaction which has been given like fractional order, can that be an elementary reaction?
No, sir.
Because order and molecularity has to be same. Molecularity can be only 1, 2, 3. So if I write the rate expression like rate is equal to K into concentration of A power 1 by 2 into concentration of B power 3 by 2. Is that an elementary reaction? It cannot
No,
be elementary reaction. Their order can never be 0, negative or fractional because stoichiometric coefficients can never be 0, negative or fractional. And for elementary reactions, you cannot have fractional order or 0 order negative. 0 order reaction can never be an elementary reaction. Fractional order is also not possible. These are the points you have to note down. First, only 2 points. Law of mass action and rate law, they are same. And order is equal to molecularity of the reaction. Molecularity can only be 1, 2, 3. So for elementary reaction, to call it as an elementary reaction, we can say order can be only 1 or 2 or 3. It cannot be negative or 0 or fractional or greater than 4, like greater than 3. For a reaction A plus B gives us two products. The rate law is R equal to rate equal to K into concentration of A into concentration of B power 3 by 2. Can the reaction be an elementary reaction? Explain.
no, sir.
Why?
Because
It cannot.
molecularity cannot exceed 3 and it
Is that
cannot
the?
be fractional.
Yes, it cannot have fractional order. It cannot be an elementary reaction as total order is fractional. The total order of the reaction is fractional, so that cannot be an elementary reaction. Right. Next, mechanism of reactions. For complex reactions, we will be introducing this concept now. Whenever we have a complex reaction, how to find out? This can be very interesting. Listen carefully. For complex reaction, you cannot define molecularity of each and every step. We have to define the molecularity. You cannot define molecularity of the total reaction. Molecularity you define for each and every single step. Molecularity of the total reaction you can assume as molecularity as the total step or slowest step, and that is the case when slowest step do not have any intermediate. Let us understand. Let us proceed first. Those reactions which complete in multi-step or in more than one elementary step are known as complex reactions. Complex reactions are those reactions which happen in more than one step. Overall reaction is 2H2O2 gives rise to 2H2O plus O2. Mechanistic approach, if you proceed, H2O2 gives rise to H2O plus O, which is happening slowly. H2O2 plus O gives rise to H2O plus O2, which is happening fastly. H2O2 gives rise to H2O plus oxygen, that is happening slowly. H2O2 plus oxygen gives rise to H2O plus O2, that is happening fastly. What is the rate determining step? Slowest step is
Slowest step.
always, yes,
Rate
slowest step
determining
is
step.
always the rate determining step. Rate determining step or RDS. Now, molecularity of slowest step can be assumed as order of the reaction and also can be assumed as molecularity of the total reaction. Molecularity of the total reaction under one condition. Total reaction if the slowest step do not have any intermediate. If the slowest step do not have any intermediate. Understand this point. So you have a complex reaction. You have to find out order of that complex reaction. order of that complex reaction is equals to molecularity of the slowest step. Molecularity of the slowest step, yes or no? In a complex reaction, molecularity of the slowest step is same as order of reaction, which you can also consider as molecularity of the reaction when slowest step do not have any intermediate. If the slowest step contain intermediate, what happens? If a slowest step contain intermediate, then molecularity is meaningless. Understand this point? You have to find out order and molecularity, right? I have given you a complex reaction. You have to find out order and molecularity. The mechanism they have to provide. From the mechanism, like if it is an organic reaction, we have to know. Like E1 reaction, E2 reaction, SN1, SN2, we have to know that. If it is any arbitrary reaction, they will give the mechanistic approach. From the mechanism, you have to just look at the slowest step. Slowest step is the rate determining step. The molecularity of the rate determining step, you can find out number of species in that rate determining step, number of reactants. Molecularity of the slowest step is the total order of the reaction. That can also be equal to the molecularity of the total reaction, but that can also be equal to molecularity of the total reaction, but in the slowest step, there should not be any intermediate. If in the slowest step, there is an intermediate, then molecularity is meaningless. Molecularity of the total reaction is meaningless when the slowest step contains intermediate. Molecularity of the total reaction is equal to molecularity of slowest step when the slowest step do not have intermediate. Irrespective of whether intermediate is there or not, order of reaction is equals to molecularity of the slowest step. Also, whenever we have intermediate in the slowest step, we have to eliminate the concentration of intermediate by assuming the fast step to be in equilibrium. Okay. So overall reaction is 2H2O2 plus 2H2 gives rise to 2H2O plus O2. H2O2 gives rise to H2O plus O, slowest step. H2O2 plus O gives rise to H2O plus O2. This is a fast step. Each step of the mechanism is known as elementary step. For complex reaction, molecularity of each step of the mechanism is defined separately, and total molecularity of complex reaction is meaningless. Total molecularity of complex reaction is meaningless when the slowest step contain intermediate. Here the slowest step contain intermediate, so it is meaningless. 2H2O2 gives us 2H2O plus O2. Same rate expression. Rate law is K into concentration of H2O2. Order equal to 1. Intermediate is oxygen. Calculate molecularity. Whenever
1.
we have intermediate, molecularity is how much?
If
Meaningless.
intermediate is there, no molecular.
Yes or no? Intermediate is there in the intermediate is oxygen. It is there in the slowest step. So whenever we have intermediate in the slowest step, molecularity is meaningless. You find out here. In complex reaction, generally molecularity of the slowest step is same as order of reaction, which can be considered as molecularity of the reaction, except when slowest step contain intermediate. But in the rate expression, do we have intermediate? That you have to find out. Not in the slowest step. In the rate expression, you have to see. Rate expression is R equal to K into concentration of H2O2. We don't have any intermediate, right?
Yes, sir.
If we have intermediate in the rate expression, then only we should say it is meaningless. If we do not have, when we do not have intermediate in the rate expression, you can say molecularity of the total reaction as molecularity of the slowest step. Order of the reaction is molecularity of slowest step. When we have intermediate in the slowest step, then it is meaningless. How to write rate law for complex reactions? For complex reactions, the overall rate of reaction is controlled by slowest step, which is called as rate determining step or RDS. In a rate law expression, rate of reaction depends on concentration of reactants of slowest step, which must be free from intermediate. In a case, if the intermediate is there in the slowest step of reactants, then if RDS contains intermediate, its value is solved using K equilibrium of fast step, assumed as reversible. The fast step you have to the fast step whatever it is there, that we have to assume as reversible, and from that we have to eliminate the concentration of intermediate. So in certain complex reaction, product may also appear in rate law expression. So if you just look at the statements, you will have only half clarity. When you try to solve it for any reaction, then only you will get complete clarity. Let us solve it. Complex reaction I have taken 2O3 converting into 3O2. This is the reaction. The mechanism is O3 is converting into O2 plus O. This is fast. O3 plus O converting into O2. This is slow. What is RDS? This is your RDS. So we have to find out the rate law. So RDS, from the RDS I can rate is directly proportional to concentration of O3 into concentration of O. So rate is equals to K into concentration of O3 into concentration of O. Can I write like this or not?
Yes.
You may ask a question, sir, this is a slowest step. No, then why are you not rating X and Y? Because order of the reaction is molecularity of this particular reaction in the slowest step. So molecularity is 1 with respect to O3, molecularity is 1 with respect to O. So rate is directly proportional to concentration of O3 into concentration of O. Rate equal to K into concentration of O3 into concentration of O. Which is the intermediate here? Intermediate.
Oxygen.
Intermediate is nascent oxygen. O3 is not an intermediate, O2 is not an intermediate, O is an intermediate. So rate law contain oxygen. Rate law contain the concentration of intermediate. So what is molecularity of reaction?
Meaningless.
Molecularity of total reaction is meaningless. And I have to eliminate this concentration of oxygen. How to eliminate the concentration of oxygen? I have to assume the fast step as equilibrium. So O3 is converting into O2 plus O, and O2 plus O converting into O3 at K2, which is happening fastly. So rate of forward equal to rate of backward. What is rate of forward reaction? K1 into concentration of O3, rate of backward reaction. K2 into concentration of O2 into concentration of O. So can I say concentration of O is equals to K1 by K2 into concentration of O3 divided by concentration of O2. So to eliminate the concentration of intermediate in the slowest step, we have to assume the fast step to be at equilibrium. Fast step is at equilibrium means rate of forward and rate of backward are equal. So concentration of O is equal to K1 by K2 into concentration of O3 divided by concentration of O2. That I have substituted here. Therefore, R is equals to K into concentration of O3. What is, like this is K3, right? Here they have given K3. K3 into concentration of O3 into concentration of O is K1 by K2 into concentration of O3 divided by concentration of O2. Therefore, rate of reaction R is equals to K1 K3 by K2 into concentration of O3 power 2 into concentration of O2 power minus 1. This is the ultimate rate expression for this complex reaction. Understood or not?
Yes.
So in the rate expression, we also have concentration of product, right? O2 is a product. We also have the concentration of product in the rate expression. O3 is the reactant. We have concentration of reactant. O2 is the product. We also have product concentration in the rate expression. So in the complex reaction, to eliminate the concentration of the intermediate, we have to assume the fast step to be in equilibrium. To eliminate the concentration of intermediate, we have to assume fast step to be in equilibrium. Once you have assumed the fast step in equilibrium, to eliminate it, you may end up with the concentration of product in the rate expression also. Right. Try to solve this. Find out the order of this particular reaction. 2NO2 plus F2 gives us to 2NO2F. Mechanism is given. NO2 plus F2 gives us to NO2F plus F. NO2 plus F gives us to NO2F. Slowest step. Slowest step you consider. Which one is the slowest step?
NO2. plus F2 is the same.
NO2. So slowest step is NO2 and F2, right? Like first step. So rate is directly
Yes.
proportional to concentration of NO2 into concentration of F2. So I can eliminate the proportionality and insert a constant. Rate is equal to some constant K into concentration of NO2 into concentration of F2. So rate law does not include concentration of intermediate. Rate law does it include concentration of intermediate? Which is intermediate here?
F. F.
Intermediate is F. Rate law do not include concentration of intermediate. So order is equals to 1 plus 1, that is equals to 2.
2.
Order is equals to order with respect to NO2 and order with respect to F2, that is equals to 2. Right? Let us proceed further. Then next comes the concept pseudo first order reaction. Pseudo first order reaction means there are some set of reactions which are seeming to be having higher molecularity when compared to order. That means whenever we have more than one reactant in reactants in the reaction, and one of the reactant is taken in very high concentration. Whenever one of the reactant is taken in very high concentration, like this is a scenario, students, A plus B gives rise to product. A is taken in excess, and we have rate directly proportional to concentration of A into concentration of B. Proportionality we have to remove and keep a constant. Rate is equals to K into concentration of A into concentration of B. Since the concentration of A is in excess, like ocean, you can see from the ocean I have removed some glass of water. Will the concentration of ocean changes?
No, sir.
No, same thing happened here. A is in excess. Some amount of A will be reacting with B, but does the concentration of A changes?
No, sir.
Although the
Sir.
reaction is happening, since the concentration of since A is in excess, its concentration will not change greatly. Concentration of A is not changing means concentration of A is constant means, can I say R is equal to some K into is also some constant K1 into concentration of B. So R is equal to some constant K dash into concentration of B. So in this reaction, what is the molecularity?
1.
Molecularity. Molecularity is 2. What is order? Order is 1. Molecularity of the reaction means number of molecules involved in the collisions. That is 2. 2 molecules are there. But what is the order? Order of the reaction is
1.
since the concentration of one of the reactant is in excess. Since the concentration of one of the reactant is in excess, its concentration is almost constant throughout the reaction. So I can say rate depends only on concentration of one more reactant. So it is having a order of 1, but molecularity is 2. A chemical reaction in which value of order of reaction is 1, but molecularity is more than 1, they are said to be pseudo unimolecular or pseudo first order reactions. Example, hydrolysis of ester in acidic medium. We all know in the ester hydrolysis, we have an establishment of equilibrium. If water is taken in excess, what happens? The reaction moves in the forward
Backward
direction,
down.
right? Forward or backward?
Forward.
So
Forward.
you are thinking of esterification reaction. Esterification means carboxylic acid and alcohol converting into acids and water. So if you take water in the hydrolysis of ester, ester plus water converting into carboxylic acid and alcohol. If water is in excess, then concentration of water is almost constant. So K into concentration of H2O is some constant K dash. So rate is equals to K dash into concentration of ester only. So order is only 1 because the rate of reaction depends only on concentration of ester, but molecularity is 2. So K dash is the pseudo first order rate constant. K dash is the pseudo first order rate constant. Is that clear, students? Is everything clear so far?
Yes, sir.
Yes, right. Very good. Inversion of cane sugar C12H22O11 plus H2O gives rise to glucose plus fructose. Again, here if water is taken in excess, the order will be 1 and molecularity will be 2. Water is in excess, then its concentration remain constant. Concentration of H2O remain constant as it is in excess. So cane sugar reacts with water to form glucose and fructose. It is having a rate of this reaction is equals to K into concentration of cane sugar into concentration of water. Water is in excess, then its concentration remains constant during the reaction, and the concentration of H2O is taken as constant. So order is equal to 1 and molecularity again equal to 2. The same type of reaction. It is also your pseudo first order reaction. Reactant taken in excess can't affect the order of reaction. Whatever the reactant which has been taken in excess, that is not going to affect the order of the reaction. Rate law is given K into concentration of A into concentration of B power 2. Find order of reaction if A is taken in excess. R is equal to K into concentration of A into concentration of B power 2. Find out order of reaction if A is in taken excess. Concentration of A is in excess. Therefore, K
R is
into
equal-
concentration of A is equal to some K dash. So R is equal to K dash into concentration of B power 2.
B
Therefore, R is equals to 2
2.
because it depends only on B, but here concentration of B raised to the power 2 is there in the rate law. So R is equal to 2. So after this, we have to study different order reactions like zero order reactions, first order reactions, second order, third order, nth order. Let us go with the reaction. A gives rise to product. What is rate of reaction? Rate of reaction is equals to minus d concentration of A by dt.
By dt.
Very good. And rate of reaction from the rate law is equals to K into concentration of A whole power 0. This is from rate law. From rate law we can write or not? Rate is equal to K into concentration of reactant whole power order. If it is zero order reaction, K into concentration of A whole power 0. So I can club these two. Minus d concentration of A by dt is equal to K into concentration of A whole power 0. This is nothing but integrated rate equation or differential equation. So I can do the integration now. D concentration of A is equals to minus K into dt. Integration you have to do. Time varies from time t is equal to 0 to time t is equal to t. At time t is equal to 0, the concentration of A is concentration of A naught. At time t is equal to t, the concentration of A is concentration of A at time t. Integral d concentration of A is how much?
Concentration of A at dt.
Concentration of A is equals to minus k. Minus k is a constant. You can take it out of integral. Integral dt is t.
T.
Time varies from 0 to t. So I can do the integration. I can write concentration of A at any time minus like upper limit minus lower limit. Concentration of
Minus
A at any time minus concentration of A at time t is equal to 0 is equals to minus k into t minus 0. Or you can write concentration of A at any time t is equal to concentration of A at time t is equal to 0 minus k into t. This is your integrated rate equation for the zero order reaction. If you try to plot a graph of concentration of A like y, you are taking concentration of A at any time on the y-axis and time on the x-axis. What is the y-intercept?
Straight line. Y intercept E naught.
Concentration of A at time t is equal to 0 and the slope is
Negative.
Minus
slope
K.
is equals to minus k. Slope is equals to minus k, which is equal to tan theta. Therefore, theta belongs to quadrant 2. Okay. So reactions in which rate of reaction remains independent of concentration of reactant are said to be zero order. For zero order reaction, rate of reaction is equal to R is equal to K into concentration of A power 0. That means R equal to K directly. Zero order reactions are relatively uncommon, but they occur under special conditions. Some enzyme catalyzed reactions and reactions which occur on metal surfaces are some examples of zero order reactions. This is all the mathematics, whatever I have discussed. We'll see the mathematics, same mathematics in the upcoming slides. First examples. H2 plus Cl2 gives us to HCl. 2NH3 converting into N2 plus 3H2 at high pressure, dissociation of HI on gold surface, reaction between acetone and bromide, adsorption of gas on metal surface. All these are going to be the zero order reactions. You have to remember the example, students. There was no other way. You have to remember the examples. At high pressure, complete surface gets covered by gas and rate becomes independent of pressure and concentration. Hence, order of reaction is zero whenever you are thinking of adsorption. Adsorption depends on what? This is a metal surface. Adsorption depends on what? This is a metal surface. Surface area, obviously, because of the unbalanced force on the surface area, adsorption occurs. Let us take all the surface points get adsorbed. It doesn't matter how much gas is there above, no adsorption will occur or not. First thing is, see, I have taken a beaker like the same water bottle. Above we have gas molecules. Let us say here we have metal. On the metal we have unbalanced forces. Because of unbalanced forces, the gas is going to get adsorbed to neutralize or to balance the unbalanced forces. Now the question is, if I am applying pressure from the top, more pressure if I am applying from the top, the gas molecule can absorb greatly. That is one point you can understand. But even though I apply pressure from the top, if all the surface area is occupied, it doesn't matter how much gas is there above, if how much pressure you apply, no adsorption further occurs because all the surface is already adsorbed. So that's what adsorption of gases on metal surface at high pressure, complete surface area gets covered by gas and rate becomes independent of pressure. It doesn't matter how much pressure you apply, surface area itself is not available. Okay, complete surface gets covered and rate becomes independent of pressure and concentration. Hence, order of reaction is zero. Adsorption of the gas on the metal surface at high pressure will have order zero. Similarly, reaction between acetone and bromine, dissociation of HI and gold surface. These are some other examples. HCl formation in the presence of sunlight, decomposition of ammonia to N2 and H2, platinum at high temperature and pressure. These are some other examples of zero order reactions. Differential rate equation, the rate equation, whatever we have derived, we'll get it. So what equation you got? Concentration of A at any time is equal to concentration of A at time t is equal to 0 minus K into T. Concentration of A at any time is nothing but A minus X. Initially, if we have A moles, after that we have X moles, like X moles has been converted. So A minus X is equals to concentration of A at time t is equal to 0 is A minus K into T. So rearrange this. K into T is equals to A gets cancels out. K into T is equal to X. X is equals to KT or not? X is equal to KT means what is X? X is a amount of reactant consumed to form product. Amount of reactant consumed to form product, that is your X. X is equals to K into T. You can find it in this manner. Differential rate equation, dx by dt is equal to K into concentration of A power 0. So if you try to solve rate of reaction versus concentration, try to draw a plot. Rate versus concentration, even though you change the concentration, rate is not going to be changing. That is why it is called a zero order reaction. So let's take the reaction A to give A to product. So do the integration. You will get a concentration of A at any time is equal to concentration of A at time t is equal to 0 minus K into T. You now try to plot a graph between concentration of A at any time versus time. This is nothing but your integrated rate equation. Concentration of A at any time versus time. If you try to plot a graph, you will get a y is equal to mx plus c curve. You will get a straight line with a negative slope. Slope is equal to minus k and a positive y-intercept because initial concentration cannot be 0. Concentration of A at any time is equal to initial concentration minus K into T. What is half-life? At
Time
time
taken at which
T
initial
is equal to T
concentration.
of concentration of A at time T is equal to half of initial concentration. So I can write the expression half of initial concentration is equals to initial concentration minus K into T half. So T half is equals to half of initial concentration, like K into T half, or T half is equals to initial concentration of the reactant divided by 2 into K. So if you try to plot a graph of T half versus initial concentration, you will get what type of curve? T half versus initial concentration. T half you can take,
Directly straight.
yes or no, you will be getting a straight line or not. Like if I try to take T half on the y-axis and concentration of A naught on the x-axis, T half and concentration of A naught, I'll be getting a straight line passing through origin. And what is the slope of this line? Slope is equals to tan theta,
1/2K.
that is equals to
1 by
1 by
2K.
2K. Yes or no? That will be is equals to 1 by 2K. Kt is equal to concentration of A time 0 minus concentration of A time t. So concentration of A time t is A minus x, concentration of A time 0 is A. So Kt is equal to A minus of A minus x by t, or x is equal to Kt we can have. X is equal to Kt. This is also equation. What is x? X is the amount of substance we have, amount of reactant that has been consumed, amount of reactant consumed. You can take a plot x versus time. X is the amount of reactant consumed. Like different plots we can plot, rate versus concentration, concentration of reactant versus time, how much amount of reactant has been consumed versus time. This is a graph. X is equal to Kt. So you got again straight line. What is the slope?
K.
Slope of this straight line is K, that is equal to again tan theta, if this angle is theta, where X is the consumed concentration of reactant. So slope is equal to K, same graph you are getting. Unit of rate constant is how much? For zero order reaction? Mole,
Equal to
late
both.
inverse,
Mole, liter inverse, time
second
inverse.
inverse. Yes, mole, late inverse, second inverse, or time inverse you can write. Half-life time and fractional time, T fraction or Tx, time in which X fraction of initial amount of reactant is consumed. Time in which X fraction of initial amount of reactant is consumed, that is called as fractional life. If X equal to A by 2, T half or T 50%, we can write X is equal to 3A by 4. 3A by 4 means what? 3/4 of the initial reactant has been converted, right? X is equal to 3A by 4 means 3/4 has been converted. So what do you call that? T
70.
T 3 by 4 or T 75%. X is equal to 7A by 8 means 7 by 8 part of the reaction has been done. So T 7 by 8 or T 87.5%. X is equal to A means what? All the reactant has been converted. So that is nothing but T
100%.
100%. T completion or T 100%. Very good. Half-life period, the time in which half of the initial amount of reactant has been consumed, the same whatever we have written earlier. K into T half is equals to concentration of A naught minus concentration of A naught by 2. So T half is equal to initial concentration by 2K. If you try to plot a graph between T half and initial concentration, you will get a straight line with a slope of 1 by 2K. You will get a straight line with a slope of 1 by 2K, and that straight line is actually passing through origin. And what is T 100%? T 100% concentration of A time T is equal to concentration of A time T is equal to 0 minus K into T. So T 100% means at 100%, what is the concentration of reactant left out? That is 0. 0 equal to initial concentration minus K into T 100%. So T 100% is how much? Initial
naught
concentration
by
divided
K.
by K. So initial concentration divided by 2K is 50 T half. That is T 100% is 2 times that of initial concentration divided by 2K. That is T 100% is 2 times that of T 50%. the 100% reaction is going to be completed in 2 T halves if it is for zero order reaction, not for every order. 100% of the reaction is going to be done. 100% of the reaction is going to be done in a 2 T halves if it is zero order reaction. If it is zero order reaction. Is that clear?
Yes.
So let us try to solve some example. The half-life period for zero order reaction is directly proportional to initial concentration of reactant. We can see that T half versus A naught is a straight line passing through origin with a slope of 1/2K. Time for completion of reaction. How much time is required for completion? 2 times that of T half. Just now we have said, right? At time T is equal to 100%, concentration of A time is equal to 0. So T 100% is initial concentration of A by K. So T 100% is 2 times that of T half. That is the time required for completion of the reaction. So zero order reaction completes in 2 half-lives. Solve this question. For the reaction A gives rise to B, zero order reaction, initial concentration of A is 0.01 molar and concentration of A after 10 seconds is equal to 0.008 molar. Find out T 50% and T 100%. Concentration of A after some time T is equal to concentration of A at time T is equal to 0 minus K into T. This is the expression. So use this. After some time, concentration of A is 0.008. That is equal to 0.01 minus K into what is the time? 10 seconds. So K into 10 is equal to 0.001 into 10 minus 8 into 0.001. So K into 10 is equals to 10 into 10 minus 8, 2 into 10 power minus 3. So K is equal to 2 into 10 power minus 4. Units I am not writing because we all know it is a zero order reaction. You can write down the units. Find T 50%. T 50% is initial concentration divided by 2K. Initial concentration is how much? 10 power minus 2 divided by 2 into K. 2 into 10 power minus 4. How much is that?
100 by 4, 25.
25 seconds. T 100% is
50 seconds.
2 times out of T 50%, that is 50 seconds. In 50 seconds, the reaction is done. In 25 seconds, the half-life of the reaction is like half of the reactant has been converted to product in 25 seconds. Right, students, we'll stop the discussion here. We have some more examples regarding first law. Those examples I'll share in the today's handout to try to solve. Tomorrow I'll discuss those examples, then proceed with the first law, like first order, second order, nth order, like that we'll proceed. Fine. Thank you all, everyone. Bye. And our classes, like the chemistry class, will be like 3:30 to 5:30. Okay.
Okay.
No issue with that, right?
No, sir.
No, sir.
All right. So so very soon you are close to the exams, right? So we have to be very careful and use this time very carefully. And all the best for you, all of you. Thank you all.
Thank you.
Thank you, sir.